So what does it mean to draw from the normal distribution?
Well, the normal distribution is a bell-shaped symmetric graph. It is specified by the mean and standard deviation, with the mean being the middle of the graph. Well, the best way to show this is through an example. Let's look at one. So, if you're looking at our city of Slovenia, great place, there's a lot of different heights, and the heights range from short to tall. So, if we want to look at these heights again, in a histogram, this is what it looks like. This looks like a normal distribution.
But what does this mean, Mr. Dr. Sensei, teacher sir?
This means that most of the people are in this average of 5'9". So it is more likely that someone from Slovenia is 5'9", rather than the two extremes of really tall or really short. Let's look at this in another way. So, if all of the heights of people from Slovenia are put into a hat, and then you were to pick a person randomly from the hat and measure their height, you would be more likely to pick a citizen who is around the height of 5'9", than say someone who is around the height of 5'4" or 5'11". So either of these extremes. So let's draw from the hat of normal distribution and see what we get. So we wrote all of the heights of the Slovenian people on pieces of paper. Let's put them into a hat. Shake it up a little bit. Let's draw one out. Oh, what do you know? 5'9". That is because it was more likely to draw 5'9" than any of the other heights.
But what about binomial distributions?
Well, the distribution is binomial if it underlies these four criteria. It's binary, independent, the number of trials is fixed, and there's the same probability of success every time. So, what does that spell? Bins. So going to an example, let's look at my boy, Big Daddy Swagmaster Nathan Dollinger shooting some paper. Here we see Nathan Dollinger. Look at those skills. Uh-oh, made it. Nothing but trash right there, if you know what I'm saying, guys. He is a 30% ball shooter. Look at that. That is the best in the league. Okay, nice, nice. Oh, look at the form. Nathan Dollinger, what's up? So, since Nathan Dollinger is an example of this binomial distribution, and he's a 30% free throw shooter, as his stats say, then if we put 10 trials into a hat, 3 out of those 10 trials will be a success, or him making the shot, where 7 of them will be a fail. So, let's look at this. If I pull out of the hat, every time, there's going to be a 30% chance that I'll pull out a success. You suck!